part of the ATL core team, and I'm glad to welcome you to today's session. So today we have an exciting discussion lined up. The topic is space, the doorway to whole new possibilities. And we have two very esteemed guest speakers with us from SSERD, which is the Society for Space Education, Research and Development. SSERD is an international organization dedicated to promoting space science among the community and creating awareness about the current inventions and innovations happening in this sector. They have various programs planned for all kinds of audiences from all age groups, with the main objective being to encourage them to be a part of the space revolution, which has already started. So we have Mr. Sujay Sridhar with us, who is the co-founder and chairman of SSERD. Sujay is one of the 50 rising stars of 2021, which was awarded by the Geospatial magazine. Glad to have you on board, Sujay. And we also have Ms. Nikita, who is the co-founder and the CEO of SSERD. She is the ambassador for studies in France, and she is also a Dr. Kalpana Chawla scholar at International Space University. She is a space educator and a promoter of girls and women in STEM. So we are very glad to have you on board today, Mr. Sujay and Ms. Nikita. And to all those of you who have joined us today, please stay tuned and be with us for the entire session because we have a very exciting announcement for all of you, which we will be making at the end of the session. So stay tuned. And if you have any questions or any queries related to the challenge or the topic in discussion, feel free to just type it out in the YouTube live. So with that, I hand over the stage to Ms. Nikita. Over to you, Nikita.
Thank you very much, Vishnu. And like you all are so much working towards the challenge and thinking of amazing ideas for the problem statements that's provided by Atal Tinkering Lab. We are so excited to talk to you, to tell you more about space, at the same time to help you all in case if you need any kind of help from our end, because we know that you're almost at your last part of the submission. So yeah, feel free to reach out to us here on the call itself, like put down in the chat. We should be able to help you during this whole program. So I'll take you all through one of the small space journey, I could say, which is actually like from history to what's happening today and what is that is going to be important in the future so that you can start working on it right now, right? So let me share my screen and take you through the journey. Awesome. Could you just confirm, Vishnu, if you can see my screen?
Yeah, we can see your screen.
Hello?
Yes, Nikita,
Awesome.
we can
Great.
see your
Thank
screen.
you so much. As I mentioned, as Vishnu also mentioned, awesome. Great. So as I mentioned, today's topic is the doorway to the whole new possibilities. I mean, we're actually going to talk about how are these TV programs getting broadcasted? How are we able to predict this weather? Like even today morning, I was seeing that there is some new cyclone is coming up. Like how did we get to know that right now, which is going to happen next week, right? And then how does our GPS work? Like let's talk about how is this even meeting happening right now, right? So for all these questions we're going to find solution, at the same time asking some other bigger questions like how is earth formed, like you know the space answers all these questions, right? Like what is beyond the sky, what can we see there, what can we do there, you know or who are we in this whole universe? It's amazing. That space is so fascinating and we would be very happy to help you to get any of these questions answered today. right? So to begin with, space, you might ask like, what is space, right? Or you all must be knowing little bit of space, but here I am today to explain you something that is never explored or never said, you know. So let's look into those topics and enjoy this whole session. So, as I said, to begin with, what is space science? We would be exploring what is important to know about space and much more things. So, so space, I can say it's a combination of various topics that you can see here, which is coming up. It's it's also the astronomy, the rocket science, satellites, spacecrafts, aircrafts, astrobiology, which helps us to know, if we can go and live on other planets, space medicine. It's about astronauts, going and being in ISS and how does it affect their life. A lot of such topics, including space law and space art. Let's explore all these in one or the other way throughout this session, okay? But for that, we have to do a little time travel. Who's ready? Let us literally go back to that thousands, or yeah, I can say thousands of years back, right? And see what actually space is and how we have been using the space technology, or like, let's say, just the space, observational astronomy in our day-to-day activities from then. Because if you remember the starting of the slide, I said, how are we using space in everyday, like day-to-day activities? But today, like just now, we're gonna go look into history and then come back to present, okay? So it's basically a story, I say. Long back, have people, their work mostly used to be to just go find food, right? Like they used to just do hunting, and then it's a night time for them is to look at the sky, because that's the only work that they used to do. And I can say that's this whole astronomy or observational space or observational astronomy started actually that what is beyond the sky, right? Because at that time, people in the night used to look at the stars, like literally formed patterns out of it, created constellation ideas. They created stories for every constellation, and much more. They even started observing, like, okay, there are like group of stars. What does it say? They literally started making patterns, as I said, and started creating stories out of it. These patterns are visible. Few are visible throughout the year, few are visible in particular months. I mean, they started thinking, how is it possible, right? And in fact, this like kind of started long back. To just give an example, this is one of the cave painting, okay? This is one of the cave painting which was recently discovered, and I can tell you that this is somewhere related to space. I want all of you to put it in the chat and see what is this. Like, start taking a guess. And tell me, what can you see in this cave painting which is actually telling something about our night sky or space and things. Put it down in the chat. We would be very happy to see if anyone gets it right. I'll also give you a hint. I mean, I already said the hint. The hint is something in the night sky, right? Okay, here is the answer. So we found this cave painting which is very old, and which, if you look at the number of years or how old this is, we got to know that this was almost like, 3,000, 4,000 year old, which means people at that time used to do a lot of cave painting, cave art, and they actually saw the sky, the stars, the constellations, and they put it here in the painting format. You can see they've literally designed or like put Orion belt of the Orion constellation, so many other constellations out there, like a lot of astronomers mapped out of this. And this tells us how old our astronomy is, or in fact, that is the reason why the astronomy part of space is called as the oldest science, because we've been using from that time, right? Like, for an example, North Star, right? North Star is something that stays stationary in the sky, and which is actually used for directions. People at that time used to travel looking at the stars, looking at the constellations, because these are the only things which could tell them the directions. And fast forward, today we use Google Maps, which is again related to space. I mean, just look at that. It's amazing, right? So did we stop at that point of time where we just looked into something interesting in the sky? No, we kept on doing, I mean, a lot of research. What more did we see from, a lot of ancient religions at that time? Like an example here, you can see the Stonehenge, which is in UK, which is said that it was built in 3000 BC. 3000 BC. That's like, I can say 5,000 years back, right? And this, if we go and see into this, or like think of, or astronomers and scientists have done a lot of research there, which actually says that they used to use this as something to observe the sky. Like you can see small, small windows or gaps, and every part of it you go and stand, they could see a different constellation. That's how this was built, to actually predict which month we are in, which season are we in, where is the sun coming up, what time is it. This is how it was built, right? Apart from that, you can see various other regions, like in Egypt, right? In Egypt also people used to observe stars and moon, um, including few regions in China, right? There also they used to observe constellations. They've done a lot of work on these moon um, eclipses, and this particular pyramid of moon, it's particularly used to observe the moon. At that point of time, people have been seeing the comets, something that could come, and they have calculated number of years it comes back. Yeah, I'm talking about comet Halley, right? I mean, the proofs, they've been noting it down, right? It's that old and that historic, um, and it's been playing a major role in everyone's life. I just spoke about history. Now let's fast forward to see what happened in the 20th century. And I can say here is where major things started happening, right? Because long back, we used to observe the sky. But then again in 15th century, with Newton, Galileo, all these people kind of came up with this technology like telescopes. It helped us to see beyond the sky. And after that, 20th century is something that again came up with major changes, or we also call it as modern space age, with working on the new idea of this something called rockets itself, or to launching the first satellite, first animal in space, first human in space. Then we also landed on the moon. Okay, we landed on the moon. We started sending huge structures to space where astronauts can go and be there. We also started launching these satellites and probes that could go outside the Earth and know more about other planets, right? We also sent our astronaut to space, Rakesh Sharma. Then we launched this space telescope. This is, I could say, in the 15th century, having a telescope, something like what you can see in my background, to someone who thought of this idea, let's put the telescope in space so that we could see much more things. Hubble Space Telescope has been that first one, which actually is giving us information till date on what are the different stars and planets or celestial bodies out there.
So,
Hubble Space
Nikita,
Telescope has helped us. Yeah,
yeah,
go
I have a
ahead.
question actually. There's one question in the chat section that we got in the beginning of the, session. So the question is the telescope in the background a real telescope? So that is one question
Yes,
that was student.
it is the real telescope, and you can actually see moon, Jupiter, Saturn. In fact, the moons of Jupiter, Saturn very well. It's beautiful to see. Yes, it's a real telescope. Yeah. So I was telling you, all these things is something that's called as modern space age, right? We started exploring what's there beyond the sky, to how the space technology can help back us here on Earth. a little bit about astronomy again, because I brought you to space technology. Yes, even in this astronomy, right, with the help of space telescope, we could observe what are the different planetary systems out there beyond our solar system. We found n number of exoplanets, and among those, we have also found few are habitable. I mean, which are very similar to Earth, where we can potentially find a life. Like this one over here is called TRAPPIST 1 system, and you can see this is a solar system kind of thing, but it's a different star system. And here you can see there are three planets like Earth, right? But for us in solar system, we only have one Earth. If you can see, it has bluish in nature, it has something white in color, green in color. So it looks very similar to Earth, which means a lot of scientists and astrophysicists are looking for life on these planets. Of course, they are thousands of light years away, which is going to be very hard for us to reach. But for sure, to know that there are some planets which are similar to Earth is something big that has happened. Apart from that, we have had other advancements, like we found water on Moon, we found water on Mars. We've been going to different asteroids to see what is there, because asteroids have some precious material which could be brought back to Earth, right? So we've been exploring all these things, and we have much more to do in this area. Let's come back to space technology, right? We have rockets which helped us to launch these satellites to space. At the same time, it also helped us to send this ISS to space, where we all are actually living. Again, the technology has developed so much that our rockets have started coming back. Just think of this idea where from the time we started launching rockets. Every time you have to send a satellite, your rocket has to be built newly, and the parts actually fall down. I hope all of you are aware of it. The rocket parts fall one by one when the fuel is over, and it's just waste. You can't use it. I mean, it's just waste, one time use. And then is when this one brilliant mind came up with this brilliant thought: why can't we build something where it goes to space and come back, and we can put the fuel and use it back? And that is when this particular reusable rockets were developed, and today it's been used so much that we use this rockets to go to space, come back, or launch the satellites. Again, it comes back. We do small changes, like if any part is not working, or you put the fuel and it's all ready to go to space. This is how the technology has been changing. And particularly to talk about these, how satellites are helping us, like satellites, you would be learning a lot after my session from Sujay, but I'm just telling you that satellites are not just used to see what's in the sky. I mean, just think, the satellites were just turned towards the earth, and it started giving us amazing results or amazing information about the earth itself. That's what I want to tell you all, that space technology, these rockets and satellites, is not just to see up out there. It is to see down, back earth, and which means it is helping all of us, right? It is helping all of us. Like you can see, it gives us information about what's happening in particular area, what is happening with water. Like for example, I think Sujay has planned to show that you can see the lakes, right? You can actually know how these lakes have been getting dried up, or water bodies. At the same time, you go to the region like polar region, how the water level has been increasing, you know. So all these information could be seen with the help of satellites. We can also see forest fires. We can see something called as volcano eruptions, everything with the help of these satellites, right? And most important, satellites or the space technology has been helping us to, um, you know, to know what's happening on the other side of the world. Like today, I'm talking here from Bangalore, but now look at you all. You all are like sitting from, stay in different part of this country and listening to me. I can say it's because of space technology, right? And a lot of applications which I can start telling that, we're all dependent on technology in many ways. If you want to order something online, again, space technology. You want to know what is weather out there, space technology. And then recently, there was one more application that everyone were talking, like agriculture, right? You can use space technology for agriculture to know that, okay, this land has this much water content, this is a weather condition, this is a soil nature, you can grow this particular crop. At the same time, there is one more idea that a company is working on, which is called, this particular satellite can get information on where exactly the fishes are more, the quantity of fishes are more, and this location are given to government and the fishermen. So they directly go there and fish. So these are the ideas that we can, we need to think of and come up with solutions. And space, as I said, ISS is one of the best place where you can do your experiments in zero gravity or microgravity. And this is actually a practice for us to go and live our life far away on Moon and Mars. Okay, it is possible. And that's why so many thousands of scientists and engineers are working on this, right? I think this is my last slide, which I want all of you to think of in the future when you all grow up. One is the space debris. This is one of the major problem that we all are facing today in space. We want all of you to think of a solution which can solve this problem, because it's just like you're at your home. Around your home, if you see junk everywhere, waste everywhere, you can't go outside, it stinks and all that, right? It's the same thing out there. A lot of satellites which are not working is in space, and it's a junk there, which means if we have to go to Moon or Mars in the future, all these things are going to come and collide with the spacecraft, and it is going to affect the spacecraft. It's just a junk there. We need to start clearing it out. And the sad fact is, still now we don't have any one solution which is out there in space and started working. Everyone is thinking of solution, and probably you can think of the best solution and clear the space debris. Another major thing, it's not a problem but an opportunity, I can say. If we have to start go and live on Moon and Mars, we need to think of food. So think of space food, space agriculture, or space farming. Very wonderful topics that you can think of for the future. Of course, one of the problem we are facing here on Earth, that is climate. Climate problem could be solved with the help of space technology. I'm not going to tell you how. It is your interest that has to help you to think of how we can use, including the urbanization. You see, so many cities are coming up. There's no water in these cities or pollution in it. All these things could be solved with the help of space technology, and you need to think of it, right? So these are the problems which is going to be very huge problems in the future, and the future is yours. You need to start solving on that. And I know you're all school students, but yeah, you're going to study more, so study in such a way that you could solve any of these problems. And yeah, I tell this every time I talk to students, that if you are looking at becoming something in the future, it's not engineering or scientist that the only options. You have a lot of options here, like we have space medicine, space law, or space art, and apart from aeronautics, aviation, and space technology, much more things out there. Just explore and try to do something new, try to do something that is going to be very important in the future. Okay, that's it from my end, and Sujay will explain you much more things. If you have any questions that regarding anything that I spoke now, please put it in the chat. I'll try to answer them. Thank you.
Thank you so much, Nikita. And before we move on to Sujay, I think there are a couple of questions that we can, discuss. So there's one question which says, is there any telescope to see Pluto? Is that possible?
There are telescopes through which you can see the Pluto, but they are pretty huge, which we can't buy at home. These are something that you can buy and operate it easily, you know. But those telescopes to see these Pluto and things, they are very huge in size. They're called observatories. So it's good you go to the observatory and see, because the condition is also required. Like, even if I have to see through this telescope, I need a clear sky. And when it is cloudy, we can't see even moon sometimes. So these observatories are set up in such places where it is too high from this, very high altitude, very far away from light pollution, and much more things. So you can go there and see.
Thank you so much, Nikita, for that. And so another question is, so you showed us a solar system, right, which had three planets that are similar to our very own Earth. So the question is, you mentioned that, those planets are thousands of light years away. Then how is it possible to get information about such solar systems?
Very good question. That's what we are capable of today. We can actually find what is there thousands of years, or like, light years away, right? With the help of the technology. If you remember, okay, let me just share my screen again, wherein it will explain you how we are able to detect those, okay? Just give me a second. So this is one of the way to find these exoplanets. Let me go to that slide quickly. Yes, you can see the first picture here, all of you students. So here it's called as transit method, or there are many methods. Okay, there are many methods. For example, if I have to see a star, you can see the star in the night sky, and whichever is visible is visible. But I'm talking about these stars or planets which are revolving, these stars which are so many light years away, right? So we use certain technologies, like here, which you can see is called as the heat gradient way. If you can see this in the center, it is red in color. So every time you remember, red means high temperature. Okay, so if you can see this, they map it with certain equipments, the whole sky, where you can find this red means it's something very hot. What can be hot in the sky? It's the stars. Okay, the stars, like the sun that you all see, right, every day. In fact, our sun is also one of these stars. Like that, around it, you can see there are some regions where it is showing cold, at the same time, around it is so hot. And they are circular in shape. They're all going, it looks like they're all in orbit. So this kind of information will give us, okay, there might be something like a solar system, right? And after this, they again do certain different type of experiments to know, okay, to capture those. In fact, the radiations, it's a lot of work, a lot of information. I could tell about this for 1 more hour, but yeah, in short, we have these technologies which will help us to find out these exoplanets, or planetary systems out there and the different stars. Yeah.
Thank you so much, Nikita, for that. So I think we'll take more questions at the end of the session after Sujay, talks. And but before that, I would like to thank you, for covering important topics. And I really like the way you said that these are not problems as such, but opportunities, to combat space debris and to find food in space. And I think these are some interesting opportunities that the students can explore to participate in the ATL Space Challenge. And I really like this slide about the careers in, in the space sector, because I think this is very important for students who would want to explore space in future. I know I was one of them when I was a student, so
Yeah.
that will be very helpful for the students. So thank you so much for sharing that. And with that, I hand it over to Sujay. Sujay, over to you.
Thank you so much. Thank you so much. So first of all, I want to thank ATL for inviting us and having this opportunity for the students. As you said, this is something which we never got when I was a kid or when I was studying in school. We never really got this kind of opportunity. First of all, I want to appreciate all of you for organizing such events. So coming back to this particular topic, so what I am going to talk about is very simple. This is one of the topics in this challenge itself. Getting the data from remote sensing satellites and finding out what are the different things happen. How do you use this data? That is an important thing. Now, interestingly, Nikita had on the last slide, she was talking about climate change and new opportunities which are available with satellites. Now, satellite, all of you know that satellites are orbiting around the Earth, taking photographs, doing a lot of measurements, and these are called remote sensing. Okay, so basically, it means it is observing whatever it can see in various ways. Like what we see is visible light, like you see red, green, blue, all the colors we see is visible light. But interestingly, satellites can see beyond that, which is basically like on infrared, ultraviolet. I'm sure you must have learned all these EM waves, like on different bands. Even it can send out radio signals and get the data out of that. Now, what I'm going to show you is a few ways you can observe your surroundings using satellite data. Okay, I'm going to go from the easiest to slightly hardest way. And at the end, I will give you one bonus, what do you say, activity you can do, because I saw a lot of interest in the, telescope, which was sitting behind Nikita. So I'm going to give you one bonus activity. Okay, so coming back to this, the first thing, what we are going to do is something called Google Earth. I know all of you have this Google Maps in your phones. Apart from Google Maps, Google also provides you with something called Google Earth Pro. Okay, with that you can actually get a lot of different data. Now there are a lot of hidden things inside Google Earth. I would suggest you go check out all those things, such as like Google Sun, you have Mars, you have Moon. All those things are available inside. You can go explore Google Earth Pro. But to start with, you can just go to Google, search for Google Earth Pro, and download it and install it on your laptop or desktop, whatever you're using. So I'm going to quickly share my screen. I have already installed and kept it ready in my laptop. So this is something called as Google Earth Pro. It is slightly different than what you generally see on your Google Map, but it actually gives you a lot of really good information, whatever you need. Okay, so to start with, how do you use this particular globe or whatever you're seeing here to observe your surroundings? So for that to start with, you need a location to observe, right? So since I'm in Bangalore right now, I'm going to just search for Bangalore, and it actually comes up in the like in the search result. It comes up and it just goes directly over there to Bangalore. So I'm in Bangalore now. Bangalore is famous for two things. Oh, I can say three things. One is for its gardens, second is for weather, and for the lakes and lakes, you can say lakes. And a lot of lakes are surrounding all the Bangalore town. And what I'm going to do is I'm going to show you uh, how the lakes or the surrounding area has been transformed. I'm just going to pick a random location. I don't have any specific place in mind. I just wanted to pick something in random. So I'm just going to go and okay. So as I said, look at this. How many lakes you can see on just one screen? Like one, two, three, four. You can see a lot of lakes. So as I said, famous for lakes. So I'm just going to pick one random lake, and the cool thing here is Google Earth also has historical imagery. Okay, so okay, I think we have a bonus lake on the side. So we can get a historical imagery, which means it is very simple. Which means you have current data. So whatever you're seeing right now on the bottom, you can see it says imagery date is 3/8/2021. Okay, beyond that, you will also see, you can see a couple of years back what's been happening on the past of this particular place. So to access that, it is very simple. You just need to click on this particular icon, like show historical data, or if you don't have that particular icon there, you just need to click on go on view and select historical imagery, which will open up a pop-up on top. right? So here you can see the current date, like 3/8/2021, and here also on top you can see it says 2021 because we are in 2021. And on the like on the last, you can see 1985, which means this particular place has the historical data from 1985 all the way to 2021. Now, I'm not going to say they have every day or every year, every month, every year. They have data of certain years, certain times, because it's all random. Google was not actually built for this purpose, but they have that data. That's it, and they are providing it for us for free. Now, what you can do is just simply scroll back and you can basically go back in time. Like someone was asking on the, call, right? A couple of Vishnu was asking, and um, how do you see thousands of years and how do you see planets? It's basically the light which is traveling from there. It is keeping on traveling, and we're just intercepting and seeing what was there. And what you're seeing right now is basically, if you're seeing a planet thousands of light years away, it is basically a lot of years back, not what is happening now. It is a lot of years back. What was happening? It is not the present. We are seeing the past of that planet. Okay, so we have same like that James Webb telescope they are planning to launch. NASA is planning to launch, which can see further away, which means we can see even past, like whatever we are seeing now, even past that we can see the past activities, how this solar system or how the universe was born, all those things. The same like that on a smaller scale, we can see how humans changed the entire landscape of Bangalore or any cities or of any place in this whole earth, right? You can just see, like, I just scrolled it back to 1985 and you can see what happened. Like, it's all missing. And you can step one step at a time and you can see what difference it makes. So if you see, that step took from 1985, the next imagery was available in 2000. You can see what kind of changes happened to that particular place. And taking each step, you can actually see what are the different things, how the lake is drying. I just took, again, I took a random place. So if you're looking for any specific place, or in fact, for those who are living in an apartment, you should actually go check it out about your apartment. Then you will know where did they actually build it. Did they build it on a lake or did they build it on actual ground where they used to, farm? All those things you will be able to see. Like if you can see here, it is all a farming area. Now scroll to another few years, you can see some buildings are forming. Again, more buildings are forming, and the roads are being developed. And you can see some, like that cluster is becoming bigger, bigger, even bigger, and there is already a new road which is being built. And you can see that farmland is getting reduced. It's going on and on and on and on. And in 2021, you can see that entire farmland is becoming buildings, like it's full of buildings. So like this you can actually get a lot of different data, which will help you see, okay, what kind of damage as humans are giving to that particular area. So this is going to be a good reference point for you to start with. Now you are becoming good at this, and you want to have some more advanced data. Okay, so for that, the next step is to download the actual satellite data. Here, what they've did is they got the satellite data, they process the data, and you are getting your final output in the software, which you're not doing much. You're just scrolling through the data. Now, the interesting part is what you can do is you can actually get the raw data from satellites and do a lot of processing to that image, find out a lot of different data. Like I'm going to take the same case of lakes. So I'm going to start with lake. Um, Now, I'm not going to cover a lot of in depth on this particular, small talk. Like we don't have enough time. I have to actually take 2 to 3 hours just telling you, okay, how do you process the data? How do you correct the colors? And how do you get the like data out of it? But I'm just introducing it to you. You can actually explore. This is a free software, which I'm going to again show you. Okay. So then the first thing we are going to do is very simple. Go to Google. Okay. I'm going to go to Google and search for USGS Earth Explorer. Since I already searched, it is coming there. So once I get USGS Earth Explorer, now India, ISRO is also providing you with some similar data. It's called Bhuvan. Okay, you can search for Bhuvan data. Once you search, you can also get that data on the website. Like you go to Bhuvan
We can't see
and
it.
you can
We
get
see
open source data.
yeah,
So
we see
sorry.
a gray screen. Are you sharing something?
Yes. Okay. Let me just stop sharing it.
Yeah.
Share it again. Okay. So are you able to see now?
Yeah, now we can see the Bhuvan
Okay.
page.
Okay. Awesome. 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 So this is Bhuvan. Again, I was telling you just go to Google and search for Bhuvan. You will find the ISRO's website called Bhuvan. Now you need to create an account. Unfortunately, I don't have an account here. For some odd reason, I never got the activation email and it never got activated, so I can't show you beyond certain point. But you can actually create the account and download the data from here as well. So for that, what you need to do is you need to select a satellite. Like you have multiple satellites. This is again provided open source from ISRO. So I'm going to just select a source sat. You can select again depending on your requirement. Now, next thing what you need to do is go to tiles, or if you are looking for a particular location, you can draw that particular location for the ease of the current time. Like I'm just selecting a tile, so I just need to zoom in and select one particular tile, whichever tile I need. For that, I need to click start and select that particular tile and then click next, which will show you a lot of different you know imageries which are available. So it also tells you which date that image was taken. So in this particular case, you can see 7th of November, 16th of February. You can see a lot of image which is available. You can see the preview by just clicking on view. You can see that image. Also, you can download once you create the account. Okay, since I'm not having that access right now, I'm just going to leave it here. You can create your account and download it right from here. So I'm just going to close this one now. Now we go back to our USGS Earth Explorer. So as I said, I just searched for USGS Earth Explorer, and the first link I'm going to click there, and we are going to get that particular data. Okay, so we got this USGS website, and you can already see I have already logged in. If you don't have an account, you can just create an account with any of your email ID. You can create an account here, and you will get a verification mail. You just need to verify that email, and you'll be able to log in. And once you log in, okay, so I'm going to get data from satellites. Okay, so what I need to do first is select the location. I don't want the entire world. So I just want my particular location where I'm in right now. So I'm just going to go to zoom in and go to Bangalore. And what I will do right now is very simple. So I need to draw a polygon, which means I'm just going to draw an outline telling that this is the area which I'm interested in. Right. So I'm going to click multiple clicks because I'm interested in Bangalore and around areas. So I can adjust according to whatever my requirement is. I can just adjust. You can explore the other options which are there. And next is we need to select data sets, which means what type of data we are looking for. So to start with, the first type of data, what I'm going to look for is elevation, like all the water bodies. So we were talking about lakes. So let's go to water bodies. So for that, you need to go to the data sets and select elevation. Okay, so digital elevation, and then select SRTM. Okay, so once I select that, I'm going to select water body data, which means it will give me all the details about the water bodies. So it's basically going to give you a highlight of water bodies. And then what I'm going to do is I'm going to click on results. Okay, so I have two different information here available, right? And it basically means I have two sets of data. So here in this particular website, you can put an overlay, right? You can see where this particular data is covered. So if you click on that, you can see that this particular information will come from this region, right? So that is what this highlighting means. Again, if I click here, it will show me it is coming from this particular region. Why this is coming? Because I have selected two parts which are in two different regions, right? So what I'm going to do is, since I'm just going to do demo, I'm going to get this data, click on download, right? So once you have your account, then only you'll be able to show download option. So once that is done, then I'm going to click download, which is going to download one file. Okay. So once that file is there, right? So once I got that file, I need to use this particular file for someone, like with some software. For that, you need a software. Okay. For that, we use something called QGIS. So this is again an open source, open source software which you will be able to use freely, right? So I'm going to, if you want to download it, you can just search for QGIS download, or you can go to qgis.org, right? And then I'm going to click downloads. So again, scroll down and whichever is relevant for you. If you are using a Windows system, you can download Windows installer. If you're using a Mac, I'm sure there is, yeah, Mac option is there. You can download for Linux. You can download for whichever uh, operating system you're using. So once you download, and I have downloaded and installed it because it's a huge software, like it comes around 1 GB. And once you open it, you will get a software like this. I know it looks a bit like Word, but it can do some cool things. So first thing is, you have to install a couple of plugins. So one of the plugins is called HCMGIS, right? And for that, you just need to go, once you install and open this QGIS software, you just need to go to plugin, manage plugin, and you can just search for, let's see, yeah. So you can see it came up all of a sudden, and you can click here and it will say install plugin instead of reinstall, because I already have it. So it will say install plugin, and then you install and then you can close it. Okay, which will come to use later on. I'll tell you how. So next is, we downloaded our water body data, right? So once we downloaded our water body data, I'm going to copy all this data into my one of the drives. Okay, I have this QGIS data, and I'm going to create one folder, and I'm going to put all that data here. Okay, so I'm going to just copy the path. No. Okay. QGIS. Okay, so once that is done, I'm going to go to layer. Okay, add layer, add a vector layer, and then I'm going to select this particular path where I had put all the files. Okay, so in that there were a couple of files. So I'm going to what I'm interested in is this SHP file, right? So I'm going to select that SHP file, click on add, click on close. So whatever you're seeing here right now, right? So you're seeing here some red color lines, red dots, whatever you're seeing here are water bodies. So this will help you find out where the water bodies are. Water bodies mean it can be lake, it can be river, anything on this particular region. Also on the bottom, if you can see here, it also tells you which coordinate or which location this particular thing, like particular water bodies are. With the help of that, you can find it on your Google map or anything. Now if I get this, it doesn't make any sense for me where it is, how it looks like, all those things, right? So for that is where this HC plugin comes help. Now what you need to do is go here, click on base map and add Google Maps, which will actually add a Google map on top of this. Now, once you go here on the side, you can see layers. You just need to move your Google map to the bottom. It'll actually highlight you all the water bodies which are there. So you can see here, the lake is here. So it'll help you find out where are the lakes in an easier way. Now that is done, you found out the lake, so you found some interesting places where you want to find your satellite images. Now let me just close this because now what we are going to do is we are going to find out satellite data. Now there are a lot of different satellites and different types of data which are available in this particular place. What we are going to do, and is use satellite data which are visible range. So for that, what you need to do is again go back to data sets. I'm just going to clear whatever I had selected previously, and then we are going to go to Landsat. Okay, so Landsat is actually a set of satellites which are launched by US to observe Earth. Okay, take photographs of Earth. So it's basically a remote sensing satellites. And we're going to go and select Landsat collection to level 2 data. So I'm going to select Landsat 8, which is the latest. So click on here, Landsat 8. You can also explore the other options which are there. For the time, because of the time constraint, I'm not going to go too much in depth about different things. Also, you can see that the resource art data is also available. You can sit and explore one day you can sit and explore what are the various options which are there. And then I'm going to go click on results. It will show up the place like in the sidebar. It will show up a lot of different satellite imageries, right? And once what I'm going to do is click on this particular image, which will actually show me that particular image laid out on top of the map which is already there, which will help me determine so many different things like what is a cloud cover. Okay, this image is going to be useful for me or not. So if you are going to study about the cloud cover, you may need images which has clouds in it. Or if you want to look at water bodies, or you want to look at the forest, you may want images which are clearer, like which you can see through, right? So I'm going to select this one. Let's see. So it has some amount of clouds. And next one, okay, it has less amount of clouds. So there are not much clouds, right? So you can see here and there some clouds here and there. Okay, so once I have that, what I'm going to do is click on download. Okay, so once that is done, so you will get a pop-up where it will ask you to download the entire file. So again, it's just 1 GB. So I had already downloaded and kept this particular data sets in my laptop. So I'm just going to ignore this, but you can click on download, which will download again as a zip file. So once you have all this, you have all these files which are relevant for you, which are already there, then you can come back to your QGIS. Okay, so you're gonna create a new project. And I'm going to start importing these imageries. So for that, you can go to raster, miscellaneous, and then select merge, right? And this will actually help you view images in a different bands. So I'll just show you how the raw data looks like. So what the image you get is something called as TIF files. So this is the actual files which was downloaded. So these are like different bands, different different bands they have taken, like different colors, infrared, radio. So it will take a couple of seconds for it to load, because it's a huge file. Like it will be like 30-40 MB or files it will be. So you can actually go see it is all gray color files. So each file is like 80 MB, right? So you can see here, you can actually make out some of the shapes and like hills and different things, the clouds. You can actually make out few certain aspects of this image. Now, once I have this, what I'm going to do is click on this, place each input file into a separate file. Then I'm going to create a temporary file, save to file, and I'm going to give some data ATL demo. So I'm going to create that, save, and then I need to add the layers. Okay, so basically I need to give them the software different layers of imageries so that it can merge and make a visible range. Now, once I have that, what I'm going to do is select that, add files, and I'm going to select the band 1 to band 7 for the time being. You can explore the other options, like they have papers and all those things are available. So I'm just going to select this band 1 to band 7 and click on OK. Then click on run, which will take a couple of seconds for it to run, which will process, merge, and put all the imageries together and give you one file which looks something similar to visible range. Now you can always do this manually, you can pull down the raw files, do the coloring by yourself. You can also try that, right? So you can explore whatever options are there, which will, there are like certain amount of settings which you can change to get better images and get clearer picture on what exactly is happening. Lot of plugins are available to make a lot of processing happen. Okay, so you can see it is the processing is happening. It will take a couple of seconds. So let me just ask. So do you have any questions till now? Whatever I have shown, do we have any questions? Because it's gonna take few seconds, like 1 or 2 minutes to process. Oh,
So,
okay.
Sujay, yeah, has it loaded?
Yes,
Yeah.
it has loaded. Okay, so I'm just going to minimize and click on close. So next is you need to just click on close. You can see it's a hazy image. It's not the clearest you can imagine, but always you can go here, double click, and then you can adjust the brightness, contrast, and different settings. Also, I need to change the bands. Okay, now that is important thing. Since it's a Landsat image, a Landsat 8 image, I need to put the correct bands. So the red bands, I have already did the reference to this. So you can see here in this USGS website. So I'm gonna find out which are the bands which are using. So you can see band 2 is blue, band 3 is green, band 4 is red, which means they are taking photos as like separate photos, right? So since we are merging it together, these are called as one band of image. Now, what visible image looks like is R, G, and B. Once we have R, G, and B, um, then only we can see a color image in front of us, right? So that is how we're going to align this together. So band 2 is blue. I'm going to select band 2. Blue is band 2, and then we have 3 is green, 4 is red. Okay, and I'm going to click apply. So you can see already that there is certain image got a bit better, and then you can adjust the contrast and saturation on different levels and get the image, make the image better. So you can adjust these values according to your image to make decrease the brightness. So you can see it becomes improved. So you can actually do a lot of corrections on this color and make this image better, and you can utilize this image for your purpose, like whatever projects you're working on. Okay, so I'm just going to stop my screen. I think this is how much I will cover now, because it's actually a very huge topic. A lot of different lot of different things you can do on this particular platform. You can do a lot of processing of images, and you can actually make these images better. Whatever you are seeing, make it better and utilize it for your project. Okay, so do we still have time? I had actually told that we will do something at the last. So do we still have time?
Sorry, I just lost the network.
Okay,
I
no
missed
problem.
last couple of lines. So I think, Sujay, you have walked the students through the tool, right? That is done.
Yes. So yeah, so I have one more small thing which I was talking about in the beginning. You said, I mean, everyone was interested in telescopes, so I wanted to show them one more last thing. So do we have enough time, or do we have to wind up? I know it's still 5 o'clock, but it'll
Yeah,
take like 2 to 3 minutes.
unfortunately, yeah, unfortunately, we will have to wind up. But if you have any links that you want to be shared with the students, we will do that.
Okay.
So
Okay.
whoever
Awesome.
has joined us today, all that Sujay has covered in his talk, all the links we will add it as a comment or in the description of the YouTube video, so that you can take time and explore those websites, because I know this is a lot of information to be processed. And thank you so much, Sujay. I'm just blown away by the kind of data that is already available out there, open for
Yeah,
use. So thank you for sharing that, and thank
my
you for
pleasure.
doing this wonderful session. And so to all the students who have been waiting for the exciting announcement, so here it goes. We are very happy to share that the last date of submissions for entries in the ATL Space Challenge 2021 has been extended to 7th of October. So you now have one more week to actually finish your projects, or if you could not participate earlier for whatever reason or because of lack of time, you have one more week to go. And I really believe that all that we have discussed today will be very helpful in actually picking up the opportunities or the problems that you want to solve, and the tools that are already out there that you can utilize and come up with solutions. So you have time, so make sure you make the most of it. So with that, I again thank Nikita and Sujay, for joining us today for a very insightful discussion. Thank you so much, both of you.
Thank you so much for having us.
Thank
Thank
you,
you.
Vishnu.